This video will cover Raspberry Pi in just 10 minutes. We'll explore what the Pi is, its hardware components, how to set it up, and how to write your very first Python program. The Raspberry Pi has become a favorite tool among digital artists and makers worldwide because it's small, cheap, and can run continuously without overheating. Artists use it to power interactive installations that respond to movement, sound, or touch. For example, you could connect a motion sensor to the GPIO pins and program the Pi to trigger a light display or play a sound whenever someone walks past. Museums and galleries use Raspberry Pis hidden inside exhibit frames to run looping video displays, generative art programs, and interactive touchscreen experiences. Musicians and engineers use it to build custom synthesizers, digital audio workstations, effects pedals, and even fully standalone instruments. The Pi can run software like Sonic Pi, which was specifically designed for the Pi, and lets you live code music in real time using a simple programming language. One of the most popular uses for the Raspberry Pi is retro gaming. You plug it into your TV via HDMI, connect a USB or Bluetooth controller, and within minutes you have access to thousands of classic games. Beyond emulation, people also use the Pi to build completely original games. You can program games in Python using the Pygame library, which gives you control over graphics, sound, and input. Robotics is one of the most exciting applications of the Raspberry Pi. Unlike a regular computer, the Pi's GPIO pins allow it to directly control motors, read sensors, and interact with the physical world, making it the perfect brain for a robot. You can wire up DC motors to control wheels, servo motors to move arms and joints, and ultrasonic sensors to detect obstacles. The Raspberry Pi can function as a fully operational web server, capable of hosting real websites and web applications. By installing software like Apache or Nginx, both free and available directly through the Linux terminal, you can turn your Pi into a server that responds to HTTP requests, just like a commercial hosting service. From there you can host a personal website, a blog, a portfolio, or even a small web app built with Python frameworks like Flask or Django. Perhaps the most fundamental use of the Raspberry Pi is as a programming education platform, which was its original purpose when it was created by the Raspberry Pi. The goal was to put an affordable, capable computer into the hands of every child who wanted to learn to code. Raspberry Pi OS comes preloaded with Python 3, the Thunny IDE, Scratch, Sonic Pi, and a variety of other tools specifically chosen to make learning to program as accessible as possible. The CPU, or Central Processing Unit, is the brain of the Raspberry Pi. It handles every calculation, instruction, and operation that your programs require. The Raspberry Pi uses an ARM-based processor, which is the same family of chips found in most modern smartphones. GPIO stands for General Purpose Input and Output. These are the two rows of small metal pins running along one edge of the Raspberry Pi board, 40 pins in total. They are what make the Raspberry Pi fundamentally different from a regular computer, because they allow your code to interact directly with the physical world. The microSD card is the Raspberry Pi's storage drive. Unlike a desktop computer that has a built-in hard drive or SSD, the Pi has no internal storage at all. Everything, the operating system, your files, your programs, and your settings, lives on the microSD card that slots into the underside of the board. The Raspberry Pi is powered through a micro USB port, or USB-C on newer models like the Pi 4 and Pi 5. This is the same type of connector used by many smartphones and small electronics, which makes finding a compatible power supply very straightforward. The HDMI port on the Raspberry Pi is how you connect it to a monitor, television, or display. HDMI carries both video and audio signals over a single cable, so one connection gives you a full visual and audio output. The camera port is a small ribbon cable connector, also called a CSI port, located on the surface of the Raspberry Pi board. It is designed specifically for connecting the official Raspberry Pi camera module, a compact camera board that attaches via a thin flat ribbon cable. The audio jack on the Raspberry Pi is a standard 3.5mm headphone socket, the same size as the one on most phones and laptops. You can plug in headphones, speakers, or any audio output device directly into this port and get sound from your Pi immediately without any additional hardware. The USB ports on the Raspberry Pi serve the same purpose as on any computer. They let you connect external devices. Depending on the model, the Pi has between 2 and 4 USB ports in the standard Type A format. The Ethernet port on the Raspberry Pi is a standard RJ45 network jack that provides wired internet connectivity. Plugging a network cable directly into this port gives the Pi a fast, stable, and reliable internet connection without any configuration required. The operating system detects it automatically. The Raspberry Pi runs on an ARM processor, which is the same family found in most modern smartphones and tablets. Unlike a traditional desktop or laptop computer that uses an x86 processor made by Intel or AMD, the ARM is designed to be energy efficient, run cool without a fan, and draw very little power. This makes it perfect for a small, affordable board like the Pi. Before you can start using a Raspberry Pi, you need to gather a few things. The essential hardware, the stuff you absolutely cannot skip, is the Raspberry Pi board itself, a microSD card of at least 8 GB, a compatible power supply, an HDMI cable, a monitor or TV to plug into, a USB keyboard, and a USB mouse. Without any one of these, you won't be able to get the Pi up and running. For physical electronics projects, you'll also want some optional hardware. A breadboard for prototyping circuits without soldering, LEDs, resistors in the 220 to 330 ohm range to protect your LEDs, and jumper wires to connect everything together. Setting up your Raspberry Pi is simpler than it sounds. Start by installing the operating system onto your microSD card. Download the Raspberry Pi Imager app on another computer, select Raspberry Pi OS, plug in your microSD card, and click Write. Once that's done, insert a microSD card into the slot on the underside of the Pi. Connect your keyboard, mouse, and monitor. Then plug in the power supply. The Pi has no power button, so it boots the moment power is connected. You'll see a rainbow screen briefly, then the desktop will appear. Follow the on-screen setup wizard to choose your language, time zone, and Wi-Fi network. The planning process is one of the most important steps in any Raspberry Pi project. Start by deciding exactly what your program will do. For our project, the goal is to make an LED turn on and off every 1 second. Next, sketch a rough circuit diagram on paper showing how GPIO pin 17 connects through a resistor, through the LED, and back to a ground pin on the Pi. Then check a GPIO pin diagram to confirm exactly which pins you are using so you avoid any wiring mistakes. Before touching any code, test your LED by briefly touching its legs to a small battery to make sure it actually lights up, and confirm your resistor is between 220 and 330 ohms. Finally, write your algorithm in plain English, set pin 17 as an output, then loop forever, turn the LED on, wait 1 second, turn it off, wait 1 second, and repeat. Having all of this planned out before you open the code editor means you are simply translating a clear plan into Python, rather than trying to figure everything out as you go. Now let's confirm Python is working. Open the terminal on your Raspberry Pi and type Python 3, then press enter. You'll see the Python interpreter prompt, which looks like 3 greater than signs. At that prompt, type the following exactly as written and press enter. Print hello Raspberry Pi. You should see the words Raspberry Pi printed on the screen below. That's it. That's your first Python program. It confirms that Python 3 is installed, working, and ready to go. Before we write a full Blink program, we need to wire the circuit. Take your breadboard and place an LED into it. The longer leg of the LED is the positive side, called the anode. Connect a 220 to 330 ohm resistor between GPIO pin 17 on the Pi and the positive leg of the LED using jumper wires. Then connect the shorter leg of the LED, the negative side, called the cathode, to any ground pin on the Pi using another jumper wire. That's the complete circuit. The resistor is critical. Without it, too much current flows through the LED and it burns out immediately. With a resistor in place, the current is limited to a safe level and the LED glows properly. And that's Raspberry Pi in 10 minutes. We covered what the Pi is, its hardware components, how to set it up, how to plan a project, and how to write a real Python program that blinks an LED on and off using the GPIO pins. You now have everything you need to start building your very first project. The best way to learn is to just pick up a Pi and start experimenting. Thanks for watching, and we'll see you in the next one.